welcome back from our little tea break, guys. Now we should be professionals with the choose function. So in the previous key skill, we learned how n choose r is always the same as n choose m minus r. So let's look at a practical example. If 15 is n and 3 is r, that should be the same as what? Okay, well, it should be the same as 15 minus 3. So it should be the same as 15 choose 12. So 15 choose 3 should be the same as 15 choose 12. Now, there's a couple of different ways that you can verify this. We can check on our calculators. 15 choose 3 and 15 choose 12. Remembering that that button is here above the divide. And you can also visualize it, that we always notice that in our Pascal's triangle, the triangle was symmetric, right? So for example, the second one to the left and the second one to the right gave us the same answer. Or the third one from the left and the third one from the right gave us the same answer. I don't know if this is going to be flipped around in post-production, so maybe it will be, no, it's not going to be flipped around. So it will be my left and my right. When I was doing my driving test, I always had to put my hands on the steering wheel like this to see which way was left and right, because I was just really bad at that. So basically, if you were going from one side, you would be 50, if you're thinking about your triangle, you would have 15 choose 0, 15 choose 1, 15 choose 2, 15 choose 3, lots of space in the middle. And if you were coming from the other side, right, you'd have been from 15 choose 15, 15 choose 14. I don't think I left enough space. Squash that up a little bit. So this one would be the same as this one. This one would have given you the same answer as that one. Squash everything together a little bit. 15 choose 13, 15 choose 12. And all the things in the middle. So 15 choose 2 will give you the same answer as that. We need another color. Let's go for orange. That one would give you the same answer as that one. Okay, so the pairs as you're moving in. Think about it symmetric. So this would be kind of like, you can imagine this is a mirror line in the middle. Okay, so find both values of x. So first of all, we can see that 4 should be the same as 5x plus 3. So 5x plus 3 is equal to 4. So 5x is equal to 4, take away 3. 5x is equal to 1. X is equal to a fifth. But that's only one value. We have to remember that 17 choose 4 will be the same answer as 17 choose. Now think about it. If one was starting on 0 and going to 1, 2, 3, 4, and the other end was starting at 17, 16, 15, where would they meet? Well, you can always use your formula. N choose r is the same as n choose m minus r. So 17 choose 4 is the same as 17 choose 4, which is going to be 17 minus 4, which is going to be 13. So the other option for 5x plus 3 could be 13. And in this scenario, x would be 2. Guys, we're flying through this. Question 3 is going to be the first challenging one. I want you to think back to what I told you in key skill 1, which is if you have a fraction that contains factorials, you always want to break down the higher number as far as the lower number. So remember that, and remember, there's a bit of an I told you so. Remember that I told you need to know this formula off by heart, or at least you need to remember that it's in the formula booklet. You need to be good at this, guys. This is the thing that everyone messes up. Right, so n choose 3. So I'm going to replace all the r's with 3. So I'm going to have n factorial divided by 3 factorial. FYI, 3 factorial is 3 times 2 times 1, which is going to be 6. And m minus 3 factorial. Now, we want to break down the higher factorial. Now, in this case, what's higher between n and n minus 3? Well, it's n, right? So we want to break it down just like we would do with a number. Now, each time we're going to be subtracting 1. n minus 1, n minus 2, n minus 3 factorial. I'm going to then cancel this off. And if this confuses you, like why can you break n down like that? Just think back to what we did in key skill 1, which is how we broke down 10. We said that 10 factorial was the same as 10, we take away 1, we took away another 1, we took away another 1. So think of this being n. So this would be n minus 1, this would be n minus 2, this would have been n minus 3. So it's the same example, but now we've got letters instead of numbers. So in this case, yeah, we can cancel n minus 3 factorial with n minus 3 factorial, which is going to leave us with on the top n minus 1 times n minus 2 divided by 6. You could multiply this out to simplify down if you wanted to work out the exact algebraic expression, but I actually think it's pretty nice and neat with the brackets in, so I'm going to leave mine like that. Now, here we go. Solve for m. So we would have here, remembering this formula, we've got here n minus 2 is going to be, I always like to go down, so if I'm going to do this, I would start by writing the formula n minus 2. Now instead of going to the side, I would write the answer for this directly underneath here, so it'd be n factorial divided by r factorial, so it's going to be divided by top minus bottom. Well, top minus bottom in this case is going to be 2 factorial. Remember, 2 factorial is just 2. So I'm going to open up my higher factorial. In this case, it's going to be n. So I'm going to open it up. I'm going to keep subtracting 1 each time until I get to my lower factorial. Now 2 factorial, I'm going to change it now just to be 2. Then I'm going to cancel this one and this one. So n minus 1, 2 times 6. 2 times 6 is 12, so we've got n squared minus n equals to 12. Now we've got a quadratic now. In A-level maths, all roads lead to a quadratic. You need to factorize this one. And it's going to factorize with minus 4 plus 3, which is going to leave us with two solutions, 4 and minus 3. And we're going to eliminate the negative solution here. So then we can check it. If n is 4, then that would mean that this would be 4, and this would be 4 minus 2. So we would have 4 choose 2, which would be 6. We can check it. Or we can check it on our Pascal's triangle. 4 choose 2 was indeed 6. So that works. I always recommend that when you get to the end of a problem and you get an answer, you go back to the beginning, plug your answer in and see, does your answer actually work? Okay, so that was some pretty complicated algebra. And that concludes, oh, we got one more. That doesn't conclude. Question 5. Once you get the hang of these, they're pretty easy though. So you're always just expanding the higher factorial as far as the lower factorial and cancelling out. You're going to be left with an equation and you need to solve it. So you've got n plus 3 factorial here. Oh, I broke my own rule and didn't write the formula. Okay. So n choose r is n factorial, r factorial, n minus r factorial. So this would be n plus 3 factorial, this would be 2 factorial, and this would be top minus, like this one always represents top minus bottom, n minus r. So n plus 3 minus 2 would be n plus 1 factorial equals 15. Now break down my higher factorial, n plus 3. So it'll be n plus 3, keep subtracting 1, n plus 2, until you get to your lower factorial, n plus 1. 2 factorial is just 2, and that's the n plus 1. Cancel that, cancel that. So what have we got left with? We've got left with n plus 3 times n plus 2 equals 15 times 2, which is 30. multiply out your brackets here. With a quadratic equation, you always want to have everything on one side and 0 on the other side. So n squared plus 5n minus 24 equals 0. That's going to factorize with 8 and 3. Okay, that would give you two solutions. N would be minus 8 or n would be 3. Now we would eliminate n would be minus 8 because that would give us a negative in here. Because if you put it back in, you'd have minus 8 plus 3, which would be minus 5. So we're looking for inside these numbers here, them to be whole positive numbers. However, if we put in 3, we would then end up with 3 plus 3, choose 2. So we can check that. 6 choose 2. Is it going to be 15? Yes. I'm not going to draw my Pascal triangle another line down. Well, we can do it. Okay. Let's go for it. So 6 choose 2. Where would it be? It would be here. That would be 6 choose 0, 6 choose 1, 6 choose 2 would be 15. Again, you don't have to use a triangle. I'm just showing it to you because you may have seen it in school. That, thank goodness, finishes off key skill 2. Key skill 3, we're going to be looking at how you can expand brackets really quickly without having to write them out x plus y, x plus y, x plus y, x plus y. How we can do that really quickly. Okay guys, I'll see you soon.